just like really fast. But we have, this building is literally falling apart. We've got leaks like once a month, I'd say, or of course there'd be water pouring onto huge expensive pieces of equipment, and it's just finally,
Perfect.
after 20 years, they're giving us a new building. So they're building it. If you look on the other side of the site,
That's
you
what
see
they're
this
building.
Crane in the air, and that's our building. So we're very excited about it. It's taken literally 20 years for them to give us the new experience. So we're very excited about that. So we are the Nutritional Biochemistry Lab. We work closely with the Food Lab. Are you guys going to get to go over to the Food Lab at all? Maybe not.
Not sure.
That's okay. So we work closely with them. We don't make the food. We come up with the nutrition requirements for the food. We do, half of our work is operations work. So we need to
This one is the most interesting. Microgravity affects the immune system. This is hard to wrap your head around. Just being weightless.
You know, just like here, touching doorknobs, various things. Okay, so we worry about all of those. Biosafety, they send up experiments, some fairly exotic from all over the world. They go up on space station. Remember, it's a national laboratory, so they're seriously doing work. And we'll send up things that are really known pathogens in some cases for science investigation. So anything that's biohazardous goes to the Biosafety Review Board, which comes out of this laboratory. Okay, we review all payloads, domestic and foreign. We do that in concert with the Payload Safety Review Panel. Actually, they changed their name, but I think that's more explanatory. For things that have biohazardous material. So then we'll come up with, you've probably heard in your lab, something that's a biosafety level 1, biosafety level 2, that kind of thing. We do the same thing in conjunction with CDC, and that biosafety level will then dictate how many levels of containment. You can send all this is where we do some of the work. This is where we do the mycology, which is like mold, fungi, yeast, okay? But I'm going to talk about now, though, what we do in flight. You know, our whole strategy is prevention, which hasn't always been quite that way, you know. I've been here long enough. Last Wednesday was 36 years.
Congratulations.
We've seen a lot of things happen over that time, and I can tell you it's much better to prevent things on the ground than chase problems on orbit. It's much more expensive to do it, and some things you can't fix in orbit. So you need to do all that preparation that you can on the ground. But in flight, we still do things. Air, water, we are the ones who set the standards. The allowable limits of bacteria or fungi in the air, water, surfaces, we're the ones who set those. So then you need some verification, right? For example, this is a little air sampler. And you all have seen Petri plates and stuff. Petri plate goes under this plate. And is this the best air sampler there is? No. Realize we got a small envelope. For example, here's, or you can pull that one.
Oh yeah, that's much
So
nicer.
that's the envelope we have on this. You know, you have a low mass that you can use. It's got to be something that's rechargeable. It's got to be something that's simple to operate. Crew has 10,000 things to do, and some experiments are very intricate. The last thing they need to do is, okay, somebody get the instructions out. And if you notice, this one's off and on. That's the way we want it. that still work, okay? So that's what we do for air, and ultimately, we even do this for them, let them grow. Water's a big deal, because like I said, water's very heavy, right? So to haul it to orbit is a big hit. I don't know what the cost per pound is, but it's more than most of us can afford. So you want to be very efficient. So one thing they do, we've done for years, the station's been up there 15 years. One thing that we do is take humidity condensate out of the air, and they reclaim that. That goes through a very rigorous treatment train, catalytic oxidizer, which gets very hot and fries the bacteria. We add iodine in this water as a residual disinfectant. Like, what do you have at home? Chlorine, right? Typically. Iodine is very similar to chlorine, so we use that. And the thing that we're looking at is, again, like I say, we set how many bacteria, the limit that can be in there per mil of water. And so that's how we verify that, is actually, oh yeah, here it is. We ultimately go up to the system, we pull a known amount of water, okay? Over this is made by Millicor, been around about 50 years. It's a field, what they call a field monitor. But you just pull it across this membrane, okay? So the bacteria are trapped on the membrane filter, right? And then it's got a pad on the back, which you add a medium so they can grow. It's like a tuberculin syringe, a little bitty syringe. You just add it to the back side of that pad. So it serves as a Petri plate. Instead of using agar, it's coming off from that Wattman filter paper is really what it is. So they'll grow. We put a little purple dye in there so you can see it, because water organisms quite often are kind of translucent. They can't take this off, so it's just a quick look, you'd say there's nothing there. So we add a little purple and it makes a little purple spot. Well, they went to taking and recycling urine. Did you know that? You guys have heard that? Okay. So that goes into the same batch, and aesthetically that may not sound too good to you, but actually urine's pretty clean. You know, if you get a lot of the salt out and stuff like that, they do that. It's usually low in bacterial counts, but it gets checked like everything else. So again, if you notice, we've talked about the air, all those risks we're talking air, and kind of see what we're doing. We monitor it 9 years before I came down here. When I came down here, I was surprised Shuttle did not have any air filtration for human health. It had a mesh that was to catch the blue fuzz off the flight suits. It goes behind the avionics. They did that because if that traps out, you're going to have a heat transfer problem. You're going to have overheating. That's why they put it. It wasn't for human health. And I was amazed by that, truthfully. So I said on station, and by the way, there's a lot of opposition to this. I said, why don't we just put HEPA filters in? Everybody knows what a HEPA filter is, right? Put a HEPA filter in, you can forget this. The engineers howled. The Delta P across that filter is going to take a motor this big. Well, let me tell you, on station right now, the U.S. segment of the station, not the Russian, the U.S. segment, we have 24 HEPA filters. That air is cleaner than what it is in this room. It's cleaner than your house. You'll come in contact with something that was released over here if the filter's over there, because it's going to slowly entrain over. So if you walk through, obviously, see what I mean? It's not perfect, but it's about as good as you can get. And keep in mind, it's a safe environment anyway. That's the premise. If you have healthy crew members, you put them in a healthy environment, healthy food and water and air, chances are things are going to turn out well. And when you think about 15 years, we've done pretty well. Well, the number one thing, because you hear this on the news, you'll hear a beach is closed due to coliform count.
Yeah.
Okay? Coliforms are found typically in feces. Now, when you see that at the beach, where it's coming from is just after a rain, the runoff through the woods with raccoons and everything else, dogs and everything, that runs into the beach, and they'll close the beach occasionally. That's the number one thing for EPA for the microbe, okay, is coliforms, okay? And that's what this is, just, it's very nice, a commercial powder. This really works well. Anyway, so you shake it up, you look at it the next day, this canary yellow is negative, this is positive. Now, I'll tell you the good news. Of all the spacecraft we've ever had, including our experience with the NASA, with the Russian Mir station, which had its problems, we have never recovered a coliform from any drinking water on any spacecraft, which again is a testament to the engineering. Okay, we got some brilliant engineers that work on this thing. So we're going to continue to talk quickly. Let's just take a quick walk through here. So that's what we do on orbit. By the way, back in there we have an autoclave, and that's what kills things and so on and so forth. This is an instrument, by the way, Vitec. There's a lot of spin-off on a contract before I came. I came in 1980. This was done in the 70s. And they did this in response to NASA. NASA wanted some device where you just take a sample, put it in there, and it's going to tell you what it is. They're still not there, okay? Not that good. You still have to have a microbiologist grow it up, streak it out to where you know that it's isolated colonies, it's one type of bacterium. You put it in a little tube, and usually when you come in a micro, you see test tube racks with tins of tubes, right? Different color. What they did is they just miniaturized it. It's about the size of a credit card, and those are the little wells. They did this back in the 70s, by the way. But anyway, that was a very good thing. Actually, we flew this. What was the number of the shuttle that crashed over North Texas? I can't remember the name of
It's
that.
just 59.
I don't honestly remember. But it had our instrument on board. That was gone, and we never got a reflight, so it's never been flown again. Not only will this identify the type of bacterium in there, what infectious disease physician's interested in, what's the antibiotic it's susceptible to. So this can also have antibiotics in it and do the same thing. So it can do IDs, identifications, and susceptibility. Yeah, I figured we were about to.
Give you the second half of your tour. Right on in. And I'm assuming Wayne Pearson regaled you with stories of culture-based methodologies and mycology and all of that. Classic microbiology is really, really cool. I mean, it's kind of funny you do something and you've been doing it that way for 100 years and it's still the gold standard. Are y'all familiar with next generation sequencing, Illumina technology?
Yeah.
Okay. That's an aluminum IC, and I keep telling everybody this is one of the biggest advances we've brought into the laboratory since we brought that guy in there 15, 20 years ago. And that is the fact that I can now take a sample, and rather than having to take a sample, culture it, bring it around, bring my isolates in, ID each one of the isolates separately with this, I can take a sample, process the DNA, and it will immediately give me a spectrum, basically telling me, okay, here are all the different types of bacteria you have. I also have the ability to do transcriptomics with this device as well, which is giving me a lot of capabilities. And this gets into some of the work we've done with blind bacteria and fungi in space. And Dwayne mentioned salmonella. We actually took, with a colleague of mine, we flew salmonella in flight compared to growing it on the ground.
Back up to the front, there was a high bay door where the crew actually came in. When the crews came back from the lunar surface, they were quarantined for a period of time for evaluation to make sure that they weren't releasing any pathogenic organisms or anything like that back into the terrestrial environment that was going to wipe out humanity. They would have been on their face for sending people to the moon if that happened. This half of the building was the original lunar curation facility where all of the moon rocks were stored. And so if you look at the building from the outside, the front half is one story, this back side is several stories tall. This bottom area was a lot of offices, airlocks, crew showers, things like that. The lunar curation facility was on the second floor, and the third floor was actually all the air handling equipment to make sure that nothing was blowing out of the building. So this entire building was actually a positive pressure relative to the environment because you didn't want anything leaking out whenever the doors opened. Right. You'll see periodically throughout there are big red buttons. Don't press the big red button.
Oh.
Just kidding, they don't do anything now. They used to be air showers. Okay, so this is one of our laboratories we use for our water quality analyses. It's pretty standard. It's a laboratory. You guys have seen them before, but we'll talk a little bit about some of the unique things that we do with regards to water quality monitoring on the space station. As you might be familiar with Annex, and they also don't pull any plasticizers or anything like that back out into the water. From a biological perspective, I'm sure you folks are all intimately familiar with endocrine disrupting compounds and things like bisphenol A that you use as a common plasticizer and polycarbonate.
This might start working too. So anyway,
Okay.
So this is our air toxicology lab. Until a couple of years ago, we take a container, a grab sample container, we pump it out, we add in some kind of marker compounds that we can make sure that our recoveries and everything are good, and then we send it up. The crew member at some appointed time will go, he'll open it up, pull in a sample, and then it sits there for X number of months and comes back down. And then we analyze it here. In this lab we have mostly gas chromatographs with various detectors to look at higher concentration things like CO2, CO, hydrogen, methane, and some volatile compounds, some higher concentration volatiles. And then in here we'll analyze it, for the trace volatile organics using GC mass spec. So you heard about how this was the astronaut quarantine facility and the lunar receiving lab?
Yes.
So it's when I first started here, I was working for a contractor off site, and they basically I had to go in for my orientation, and then they said, okay, we'll go to building 37 and find, whoever. But the problem is that you come to this building and you see how the hallways are, and there's no rhyme or reason where anything is. So it was a little scary. Yes, did they tell you all about that room?
No.
Okay, well let's go take a look at it. Sorry,
No, it's okay.
I don't know, what all I could talk since since when I started, I was doing the lunar dust stuff. I became like an Apollo nerd, and so this is what we call the pit. It's the lunch area. Not many people actually use the lunch area at your desk. This is actually where they brought in when they brought the crew back for Apollo 11, 12, and 14. They brought them in the quarantine trailer. They back it up here, take the crew out. This is also the room where they brought the command modules back and stuck them in, because of course at the time, they were potentially contaminated too. Mm-hmm. So they would bring everything back, and this was kind of the room where they received the command modules. Down in the back hallway, they have a. Did they tell you all about the basement?
No.
Okay. Oh, who gave y'all your tours? There's actually a basement that is 6 stories down, and they built that so that they could do radiation analysis of the samples without any sort of background radiation from the cosmic rays or anything like that. So it's pretty cool. And then they had this huge vacuum system somewhere about 20 feet down there. You can kind of see some discoloration in the wall, and that's where they had the separation between the quarantine area and where everybody else could be. But they had huge vacuum systems here, and
when we talk about quarantine, it was full quarantine. Nothing was released to the atmosphere. We maintained a tank farm in the back. That's currently where we store all of our compressed gas cylinders. We didn't call it the tank farm because of the gas tanks. There were large stainless steel holding tanks out there that all of the sewage from the building was actually maintained in those tanks until it could be tested and verified that it was safe to be discharged into the municipal sewers. Hey, somebody bought those things. They're not back there anymore. They sold them off as government surplus. Somebody came and hauled them out of the building. Yeah. Some of the other interesting stuff. I'm sure Billy told these folks that this used to be the high bay where they brought everything in, right? Operates out. Had a full medical clinic here for all the monitoring for the crew members and everything. Oh yeah, you know, so as a lot of the monitoring, when you think about how you're monitoring crew health and safety, we used to do a lot of nutritional analysis on spaceflight food samples to make sure that the astronauts were getting all their recommended daily allotments for minerals and things like that. And we also do a lot of research on human body and how it metabolizes nutrients and how it retains nutrients. So if you're going to monitor what's going in,
You gotta monitor what's coming out.
exactly. So we used to have a lot of poop samples on ice. Yep.